Intermediate School District. Kira, would you introduce yourself?
Yes. Hi, I'm Kira Ingraham. I'm a mathematics specialist for grades 6 through 12 in Ypsilanti Community Schools in Michigan.
And Kira and I have been working together on a numeracy project. We've both become very passionate about working with our secondary teachers to help support their work in the classroom and learn more about numeracy and what this is all about as it's changing in our elementaries as well. So we're going to go ahead and get started, and we'll have our contact information at the end so you can contact us if you'd like to have personal contact with us or if you'd like more information. As you can see from the agenda, we have 6 topics, and so we're hoping to get through these in our allotted time. But I think what's really important is that we understand what numeracy is and why it's important for our secondary teachers to learn about numeracy. We're also going to take a quick peek at strategies and models. This is something that Kira and I would normally put 3 days into. So it's going to be a very brief introduction to these, but then we want to share with you what this big picture is all about and what teachers have to say about this. As we're beginning, we normally have some norms, but I think we're going to slip right through these. I don't think they'll be necessary for today. So you also have access to a few handouts. One is a notes page that might be really helpful for you if you are watching this video, and if you can't find access to those, we're happy to send those to you. Another is a sheet of strategies with very common names that I've put together for you. That would be very helpful if you have a longer PD, but for the sake of today, you may hear us refer to a few of them, and you might want to investigate some more that are on that list. I think it's important when you're working with teachers in the secondary world to consider your understanding of what you know about numeracy already. So having an understanding around what is numeracy in mathematics, and specifically, what is numeracy in the secondary world? These are really big ideas because we've thrown that word around having number sense for years and years, but very often it means something different to different people. So I'd highly encourage that you'd work with other people in your departments and watch the video together or do a study on numeracy and make sure that you can decide for yourselves, or you can come to a common understanding of what numeracy is in the secondary world. I also think 2 other important questions you should ask yourself is, how do we teach it? I was a certified secondary teacher earlier in my career, and I know that I've had students coming to me who were at the 3rd to 5th grade level in mathematics. We're talking students who were struggling with multiplication and division, particularly with certain sets of numbers like fractions. And I didn't know how to teach students to have better skills in this area. So I think we need to decide, how do we teach this? And we can always say, well, it's the elementary teacher's job, but let's face it, we will always have students that come to us that are having difficulties in mathematics. Hopefully not at the same numbers, but that will be there, and so it's up to us to learn how to support those students. The other thing is, how do we assess it? There's been a lot of conversation around time testing for students and the impact that assessment has on students' disposition. Again, we could put another day's PD into this for a full day, but another very important question for you to think about and discuss with your colleagues. So this is one of my favorite graphics that comes from Pamela Weber-Harris's book called Building Powerful Numeracy. And here she defines what numeracy is. The Common Core actually defines it as accuracy, flexibility, and efficiency. Students being able to look at sets of numbers that they're being asked to manipulate and be flexible in their choices so that they can be efficient in finding their solutions. Pamela Harris takes this a step deeper and says, Well, there is a place for speed in this, but there's also a place for creativity and sophistication and students being clever and interested and engaged, which all goes back to their dispositions in mathematics. There is a place for algorithms, and there is definitely a place for mental math that I believe we've left off in the past. Now, I had a tough time wrapping my head around numeracy, or the difference between flexibility and automaticity with numbers. And especially coming from a secondary world, I tried to wrap my mind around what is almost the flow chart for this. And I think that a lot of math teachers think in this way, wanting to know what comes first, what is the next step that students should be able to do, and so on. So this is one of my favorite graphics to help teachers wrap their minds around, again, what numeracy is and why it's important. Students first start out with some procedural knowledge. Of course, we want them to be accurate in finding their solutions, but they have to use strategies to derive their facts. For example, a student may not know their multiples by 4, but they might be able to double and then double again. So 6 times 4, 6 doubled is 12, and then 12 doubled is 24. So 6 times 4 is 24. They need a procedure, but they've got that in their back pocket. It's not strictly memorization. Next comes that speed and accuracy, when students have had enough exposure to working with those numbers and using those strategies over and over again. They've become faster at what they're doing and continue to remain accurate without having to memorize. The students relying on less derivation of the strategy, using the strategies, more on recall at this point. The student has achieved automaticity when they can recall all these math facts from their memory without having to use any of the strategies. It's a lot of people have known as memorization, if you will, but it's where students in the past for many generations have been expected to jump in, just memorize them. And it's really frustrating because if students were able to just memorize them, then they would have memorized them in the previous 6, 7, 8 years before they came to see you at a middle school or a high school. Finally comes computational fluency, where students can use those basic skills or that basic skill knowledge to determine the solutions to numbers that are even larger. Going back to those ideas of doubling and doubling to multiply by 4, or double, double, double to multiply by 8. But instead of needing that for the basic skills, now they're using those with much larger numbers. And they're able to multiply double digits and triple digits in their head by using these strategies. So that's the progression. This is another one of my favorite graphics because it talks about why the need for numeracy. You know, it goes back to teachers in the secondary world saying it's really tough for us to give up some time to these basic skills that students should have had before they came to us, that they should have automaticity with, but you can see the data is showing us that they don't. So I think this is a very powerful graphic. If you look first at the black bar, we're looking at the target grade, and the expectation is listed below, so basically along the x-axis. So the first bar on the left shows addition at grade 2. That would be the target grade being to add with some larger numbers, perhaps not using hundreds or above 100, but to 100. And we see that only 36% of our second graders across the country, out of a sampling of over 435,000 students, was able to accurately solve these problems. We noticed that it increases a little bit, but is very comparable in grade 3 when they're looking at subtraction. Now keep in mind, students start working with subtraction in the first grade. I mean, they're working with it very informally in kindergarten, but really formally in the first grade. So we aren't asking students to demonstrate some skill that they just learned. These are skills and strategies that they've been working on for a few years, and we still have 38% of our second graders that are capable of solving subtraction problems with automaticity. And it just continues to decrease from there. You can see the numbers. Multiplication is 29% in grade 4, division is 24% in grade 5, and then 14% in grade 6 work with fractions with the 4 basic operations. This is really, really frustrating, knowing your students are moving on to upper grades and these are their skills. Well, of course, they have more exposure to it over time, and so when assessed in the 6th grade on all of these assessments, it showed quite a bit of improvement with addition and a little bit with subtraction, but virtually no improvement with multiplication and division by 6th grade. Students were performing, fewer than 50% of our students were performing proficiently on multiplication, division, and basic operations of fractions. So the demand is there for secondary teachers to continue this coursework with students, and it demonstrates the need for teachers to understand these skills. This is one of my favorite videos around a gentleman who, yes, he was representing a particular company that sells a math product, but he brought some research with him to NCTM just a few years ago. So I'd like to take a few minutes to listen to what he has to share.
And these are not just sort of abstract concepts. It's a very exciting time in cognitive science. I'm not a cognitive scientist, but I'm going to walk you through something I think is really interesting. In terms of studying automaticity and fluency, the wonderful graphic that you're looking at right now, it's a little bit faint, but don't worry, it's going to get better in a second. This is an fMRI, okay, functional magnetic resonance imaging. It's basically cross-sections of your brain, and they're looking at brain activity. And this is one of the pioneering studies from 2005 where they were using fMRIs to look at how does the brain change over time as a result of developing automaticity with math facts. We have all these things like working memory and all these ideas, but like what's actually happening in terms of functional specialization of your brain? Turns out quite a bit. Okay. Now this is the original graphic that they had in that journal article where they're labeling all the brain regions, and if you can sort of see, some of the regions are blue, and some of them are color-coded more like an orangey red. Okay, that's a very salient difference. What they were looking at were kids who had, over time, had developed a certain level of fluency and those that did not, that were still using conscious, effortful methods for getting math facts. And they give them tasks involving math facts, and then they scan their brains. And what they're trying to do is look at the average of brain activations and figure out what's different between a kid who's using an effortful method and a kid who has that fluency. So what I did to make it a little bit easier for us non-cognitive scientists is I pulled out some of the colors, okay? So now all you're seeing is the blue, okay? These are the kids who are using effortful methods. And the takeaway here is that in all the cross-sections, there's a lot of the brain that's lit up, especially in the prefrontal cortex. So they're using a lot of the kinds of parts of the brain that we'd actually want them using for the more advanced procedure that you're trying to teach them, like adding fractions with unlike denominators. Okay. Once a kid has developed automaticity, that's the part. They're using more of the back of the thing because they're just retrieving facts from memory. Now, we of course are educators. We want kids using their brains. We want them using their brains on the right things in our classroom at the time. At a certain point, sure, they're learning the math facts. But very soon thereafter that, we want them to utilize the math facts when they're adding fractions with unlike denominators or something like that. So you can see how when you've got this very precious finite resource and your brain is sort of lit up like a Christmas tree, just with the math fact part of it, what's left for the thing that you're trying to teach? Okay. And so Menno in 2010, he was actually one of the people who was part of that 2005 study. To summarize the text up there, what they're basically saying is, if the prefrontal cortex is loaded with just the process of coming up with the math facts, there's a problem. There's a computational load there. So what we have to do is figure out teaching strategies that as quickly as possible through efficient repeated practice get it back so that it's being retrieved from long-term memory. Because they basically look at the brain, and this is going to be a simplification, like a couple of boxes of functional parts, right? Where you have fact retrieval, you have executive control, and you have computation and working memory over here. And if the executive control and the computation are consumed with your math fact process, you don't have that finite resource left for the things that you do.
find that a very effective video to watch because it helps us to understand this need that our students have and how they are sabotaging, or we are contributing to sabotaging their work if we don't support them on these basic skills. I'll often hear from administrators that, well, students who are struggling with their basic skills can be given a calculator and just put in the classroom to move on because they can still understand algebraic ideas without that numeracy. Absolutely, you're right, they can, but it's not going to take them far. They are going to struggle so much with the numeracy of it all that even if they understand the algebra, they will have difficulty with completing the tasks, as you see from that video. Their brains are full, in essence. They're full and they're tired and they are overexerted, just as if you were exercising any other part of the body and they just couldn't exercise it anymore. The other thing that I really wanted to point out was in the Common Core, we have some specific fluency standards that we are trying to work with our students and with our elementary teachers to help students to be able to do these skills. So it is an expectation. And we do continue to try to grow in these areas, but as I mentioned, we will always have students who may struggle with math, so how do we help them? Well, let's take a look at some of the strategies or some of the tools that can contribute to students having success.
Next slide. Are you turning it over to me, Linda?
Absolutely. Just take it away.
Okay, so you do have the handout of some of the strategies, and we just wanted to give you some samples of the strategies that my teachers in particular have been working with. They were trained during the summer, and they started teaching students these particular strategies in the classroom. So we have open number line, area model or arrays, and we have the ratio table, and then we have problem strings. So your open number line can be used to add and subtract, and you can use it with whole numbers, decimals, fractions, integers. And the nice thing about this particular strategy, it is something very simple for the students to use. It's easy to use this on paper. So they can use any kind of sheet of paper and they can easily use this particular strategy. And that's kind of the nice thing about most of these. So it does kind of become that mental math, or you just having a scrap sheet of paper or something on a whiteboard. So for using the open number line, we can solve some addition problems. So take a look at the three problems that we have there on the screen: 54 plus 39, 33 plus 26, and 79 plus 24. And as you look at these, you immediately, or at least most of the secondary teachers that I, and myself would do, is we're going to line this up and we're going to add them up and do the carry, and that's it. But many of our students have trouble with not only place values, but a few other things. So what we do is we will do a couple of different things. They can place this on the number line with 54 and the 39 and take some jumps to what we call friendly numbers, or taking small chunks and going that way. So from 54 we can count up, or from 39 we can count up and add those numbers together. But a friendly number, or an easier number to add together, would be, instead of it being 39, we could use 40. And if we're using 40, then what happens to the 54? Because 39 had to move to 40, we added 1. So we have to also add 1 to the other numbers, so then that's 55. That way the numbers stay balanced. So go ahead, Linda.
Oh, that wasn't me.
Oh, sorry. Okay.
Wasn't me, sorry.
That's okay. So that way they can do 10 and they can do over and back. So from 40, then I can add another 10, and that gets me to 50. And then I can add another 5, and that would get me to 55. So that would get me to, oh, I'm subtracting instead of adding. But it's hard to do it not on the whiteboard is what I'm finding.
Yes.
I really need to use the whiteboard, but I'm afraid everything's going to go in a disarray.
Well, what I really like about how Kira's sharing her strategy with you is that these numbers lend themselves to students thinking in a certain way. And often when we talk to secondary teachers, they'll say, well, kids are just sort of willy-nilly picking any method that they want. No, not really, because remember our definition of numeracy. And our definition of numeracy said that we want students to be flexible but efficient. So there might be 4 different ways of doing this problem, but which one is really efficient? And Kira really hit on that. She said, why would I add 39? I could add 40, and then I only need to come back 1. I only have to compensate for that 1 that I added in by taking it away later. So 54 and 40 would be a much easier problem for students. So for them to jump 40 off of 54, they know they're at 94. And then they just come back 1 and they're at 93. So that problem just lends itself to being what we call an over and back strategy.
And for 33 plus 26, maybe a little more challenging. So students do have to understand how to come up with 10 so that they can recognize that. So for 33 and 26, they may have a little more difficulty seeing that, okay, I'm at 33, maybe I could go down to 30, or if at 33, how could I just make it 40 or make it easy on ourselves? So not every single number will immediately lend itself for the student to come up with that nice, simple, friendly number. However, the next one, 79 plus 24, a student usually can recognize that that 79 can be 80, and then they can, again, work on getting to 100, the 80 plus 20, then they can add the 4, and they can take back the 1. And it is kind of a mental math, but they're doing all of this on the number line. And they're going back and forth, and they're watching how they are adding or subtracting their numbers to come up with the solution.
Another really beautiful thing about this tool, and remember, we aren't using the number line just to display numbers on. We're actually using it as a tool, but it really starts to help students with that idea of place value. So if I'm going to jump 40, or if I'm going to jump 30, or if I'm going to jump 20, I'm pulling apart the 10s and the 1s, and students eventually can start thinking about these by decomposition, or using number bonds you may have heard of. So they're going to decompose, or they're going to split numbers. But these are those baby steps where students first figure out, how can I split this number apart in a way that would be efficient?
And that truly shows their understanding of the numbers. That's something that is what is lacking for our students in numeracy. Another model or another strategy is the area model and arrays that can be used for multiplying and dividing. And again, you can use this for your whole numbers, decimal, fractions, and integers.
You know, I'll be honest, when the Common Core first came out and I saw that one of the Fluency standards was that students should be able to multiply multi-digit numbers together mentally, I just thought, oh my gosh, you've got to be kidding. How can kids not do these without paper and pencil? How can they do these without paper and pencil? I just thought there's something missing here, and there absolutely was. And so Kira's going to talk a bit about that multiplication process, but I think it'll help you to understand your students when they're coming to you and doing these things in their head and you really don't know what they're doing. Ask them about their strategies.
And for this particular strategy, you may have heard of like the lattice method, some other kinds of the different arrays, but basically for our 15 times 12, a student can break that down that it's 10 plus a 5, and then there's 10 plus a 2. I'm really tempted to go ahead and try to do the whiteboard.
Go ahead.
I don't know where it is. Oh, well, maybe I could just try that. I'm going to try this. Oh, wrong, not a good color. And you've seen this before. So I've got the 10 plus the 5. I got so excited sometimes when you do this. You normally, you just look at it and it's like, oh, I'll just multiply 10 times 15. It's no big thing. When you really have to sit down and think about it even as a teacher, because you're just so used to using those algorithms that you really have to kind of sit down and think about it. So here it is similar to that kind of array or lattice method, but now you're doing 10 times 10. Many of our students can do that 10 times 10, which is 100. You're doing 10 times 5, and you're getting your 50. You've got 10 times 2, and you're doing your 20. And one of the other things that I like about this and the next method we're going to talk about is because it really does get them ready for Algebra 1, doing the linear, using tables, and that type of thing. It does get them used to that, so it's not so foreign. And you got 2 times 5. And what you end up doing is you add everything up. So you've got 100 plus 50, you've got 150. And then you've got 20 plus 10, and you've got 30. And together, 180. And of course, all the teachers, as soon as they did this, we went back to the old method and checked it to make sure. But yes, it is 180. But because, again, you're not used to that, doing that whole decompose, that breakdown, and realizing how these numbers are truly related to each other. Because here you would put that little plus sign in the middle there for those two numbers to be added together. So you are still doing 15 times 12, but you're breaking it down into smaller chunks, and that's really helpful for the students to understand. Just like this one, 19 times 13, a student can see that, and that can just block them. And they're just like, there's no, I've got to do all this, I got to carry, I got to do all these things. But in all actuality, you've got 10, you got 10 times 10, so you got 100. You've got 9, and you got 3, and you can sit down and you can start figuring that out and make it a little easier, even if you had to break down a few of the numbers a little bit more. But that 10 times, breaking it out and having 10 and 9 and 10 and 3 is a way easier thing for most students, and they can comprehend that, and they can follow this organizational understanding of how those numbers are related.
And very often it's at this point that we see the light bulb go on with teachers, because just the motion that Kier was just doing, like arches or arcs with the 19 times 13, probably looks very familiar to teachers, which secondary teachers would call FOIL, when they start distributing with variables in binomials. So there's a very clear connection between students understanding this strategy and understanding how to multiply binomials. And we're going to talk a little bit more about that in a bit, but this could just as easily be x plus 9 times x plus 3. So teachers could then see a direct application into their content, but if students can't do this with whole numbers, they will struggle with it with variables.
And I just want to, more challenge, it is a challenge, especially to we're just used to it, especially, us OGs who are teaching, we're just used to it. But even down here for the 399 divided by 19, you can start combining different methods. So, 399 is so close to 400, 19 is so close to 20. You can help students with their estimation, and most of the time our students really struggle with estimating. And that's another thing that all of these numeracy strategies lend itself to, is that you can get close to numbers and really understand if you're correct. All right, let's stop that, and let's go on. Ratio table. So, of course, ratio table using to multiply and divide is an excellent lead into doing linear equations, graphing, and all these wonderful things that we have to do and have to understand for our students as they approach high school. So I really do like the ratio table quite a bit, and especially because you can combine some other little strategies of halving and doubling in order to really get to some of the numbers that you need, and plus, it leads right into slope, which is great. So in this one, if each candle costs $5, how much will 50 candles cost? So we know that one candle, and we set up our table, we have them set it up the same way. We could talk about what's dependent on the other, what the X was Y. There's many things that as a secondary teacher I can lead off of this. But I know that one candle is going to cost $5. So what would 2 candles cost, that kind of thing. But, you know, I'm pretty good. I can say, okay, how many would 5? So what's 5 candles? Okay, I know that's $25. And I can double this, or I can go by tens, or I could have jumped. And now I've got 10 candles would be 50. So now I'm even jumping further, and the question is how much will 50 candles cost? Well, I already have on my ratio table, and this is what we talk to the students about, is like, well, you've got 10, and if you know 5 times 10, and a lot of students know 5 times 10 is 50, and they would know that it's 5 times 5 is 25, add the 0, and they would get $250. So it made that easier. They didn't have to do everything in between. Same thing with 15 candles. So if I've got 10 candles is $50, then I'm like, oh, well, here's 5. Well, 5 and 10 is 15. Then it must stand to reason. So there's a pattern that you're finding. And that's another key element for our students. So now I'm like, oh, well, if this is 5 plus 10 is 15, then I can do 25 plus 50, and that must be $75 for 15 candles. So those are those kinds of things that the ratio table can help you with, is that you can pick certain numbers that you know easily how to calculate and then get numbers that are in between by using the information that's there. It's very helpful. And again, it just gets them trained for using their X and Y tables and the graphing and all kinds of things with solutions.
And similarly to the open number line, the number line was being used as a tool, and so is the ratio table. It isn't being used to simply display numbers like what our students are so often used to doing. They're actually learning how to use that table to organize their thinking and to help them finish a math problem, very often set in context. And we know how difficult it is for students to organize their thinking in a story problem. So they can now use the table as a tool to help them with the solution.
That is such an excellent point, because now they know why they're doing the table, because that table is literally going to help them solve the problem. So for division, and we have, how many dimes can you get at the bank if you have 105 cents? So I did play with this a little bit. If I can get I want the little thingy. Okay. So if now a lot of the students will put this in a very nice order, which is great, but I kind of went through and I was playing with this like I would as an adult, and as I've seen a few students kind of do it. So they got this. So first things first, they got to know how much a dime is. They got to know how much a penny, you know, where the pennies are coming from, and recognizing that this is 105 cents, a dime being 10 cents. So I just immediately put down that, well, there's got to be, of course, there's got to be 10, again, you little sucker. There's got to be 10 dimes. So if I have 10 dimes, 10 times 10, and tell me if I, you know, because it's the number of dimes, gives me 100. So I've got 100 cents. So I got this extra 5 hanging out there. Well, I only have 2 choices. So then I would have to have 5 pennies to make up the difference. And then I started playing from there. And so I said, well, what if it's not 10 dimes? Could it be less than 10? I said, well, sure, I could have 8 dimes, and 8 dimes would give me 80 cents. Well, what do I have? What's going on? What's left over? It's really kind of, now they got to start and think to bring a whole different thing. So I can put 8 dimes in there, but I've got a pretty big remainder is what I have now. And so I think I was correct in coming up with it was 25 cents. You all need to check my math. So it's 20. So from 80, and again, I'm using a different strategy. From 80 to get to 100 is 20, and then 5 more cents, so that's how I came out with the 25. So again, as students really get into this, they can manipulate and put in different strategies with all of these tools, and they're doing mental math. We don't need a calculator, and they become very fluent, and their accuracy increases.
I think for the sake of time, we're going to skip over this slide so that we can get through a few more important points.
Yes, these were just additional samples of, ratio tables and how you can end up setting them up and having them with the story problems, which is extremely important. I think this one too.
So I'd like to talk about problem strings. This is another really big idea in the work that Kira and I do with teachers. A problem string is literally a string of math problems that will help guide students down, I like to say a neurological path, but it's a way of mental thinking about the math. So it adds structure to your number talk, or to maybe a little part of a lesson that you're doing. It's a series of related problems. We like to call them helper problems. And it's intended to facilitate connections in the learner's mind. That's what I was saying about this whole neurological path sort of idea. There are certain problems that lend themselves, and you can influence students to begin to think that way without coming right out and intentionally saying, here's the strategy, let me teach it to you. Because then you're doing nothing more than teaching them an algorithm that they don't have an understanding of. This guides their thinking. So notice we start with 42 plus 10. This is one of the helper problems to activate prior knowledge for our students. So we have to know where they are, where is their cutting edge that we can start from and build off of. I know that I can do friendly jumps by 10. So 42 plus 10 is 52. We'll give them another similar problem, another helper problem. 56 plus 10 is 66. Now we build off of the 10 a little bit. So we're slowly working our way up to where they might have a greater challenge. So 56 plus 10, well, if my goal is to get students to start thinking about adding, 56 plus 12, we're trying to get them to think about adding numbers by breaking them into place value. I've activated that prior knowledge so the student will start thinking, well, I know 56 plus 10, I just did that. Now all I have to do is add on 2 more. So then you give them another helper problem, but maybe only 1 helper problem instead of 2, and a small string of just 2 or 3 problems each time. Normally students might come to class and see a problem like 136 plus 42, just put on the board, very basic, very straightforward, and the students would do nothing more than lining them up and treat them like a set of digits, the number 1 sitting next to the number 3, sitting next to the number 6, instead of seeing that as a conceptual place value problem, which is what we're trying to guide them into. So let's take a look at the next slide. Thinking about a problem like 25 plus 24. So if I've been working on doubles with students, or if I've been working on the parts of 100 with students, I might first give them a helper problem of 25 plus 25. So if students have that prior knowledge activated, oh yeah, 25 and 25 is 50, so 25 and 24 is just going to be one less than 50 because 24 is one less than 25. You can just guide them down that path with a series of helpful problems. And this doesn't mean that we run through all the strategies, a separate strategy every single day. They might need to have multiple experiences with it before they really are solid in it. Remember, it's this idea of having automaticity and fluency. They need to be able to be exposed to it and practice it many, many times so they have this under their belt. Not just knowing how to use the strategy, but when to use the strategy. So we've included 3 other problems there for you, another addition, subtraction, and a multiplication problem that you might play around with a little bit, or perhaps with your colleagues, and think about what problems would I give students first to activate their prior knowledge.
So as I mentioned earlier, my teachers here at IPSI during the summer went through training with Linda, and it was wonderful, and everybody got very excited about implementing this new strategy. We've all, as secondary teachers, faced students who come in and they just seem to just not like math. They don't like math. They're having trouble with math. They're struggling. People have told them that, you know, you either are gifted and have a math aptitude or you do not. And their families say that, and many educators have said that. Not necessarily math teachers, but other educators are like, well, yeah, that's why I teach English, because I don't do math, that type of thing. So we were really working against quite a few things. So the teachers were extremely motivated once they have went through the numeracy training this summer. And they're going to do some more, coming up this summer as well. They want to expand on their knowledge. So we did have the 9th graders all learn numeracy from the beginning in September. And by October, we were taking the NWEA testing, and one of my teachers was so elated because students came up to her, asked for scrap paper, and said, is it okay if we use the numeracy strategies for the NWEA? So they don't have a calculator or anything, but they felt that maybe they would be cheating if they used all these new strategies that they just learned. They had learned the open number line and they had done the doubling and the halving. And the teachers were like, of course, here, have your scrap paper. She was so excited that some of them, it was really kind of catching on that something that they could do, because again, a lot of these students hadn't been able to do any kind of mental math before, and this was kind of giving them what they were able to do. So students get quite frustrated in the beginning of doing this numeracy because of their lack of numeracy, their lack of true understanding from long, long ago. But you do have to persevere through it, and actually you have to work as a teacher, an educator, of breaking that using that algorithm all the time, especially for adding and multiplying. They're doing that same old thing, and you're trying to get them to use an open number line, use a ratio table, and they get very frustrated. But again, it's showing that they understand the numeracy, not just the plug and play, that they understand how the numbers are related together, how halving can help you, how estimation works. So this numeracy basically also helps with the brain connections, and we know that the brain has to have connections in order to learn, and not knowing those multiplication facts and not having that memorization is kind of the proof that the connection that is needed for students to retain that knowledge is not there, because they are not understanding how to have a friendly number, and they're not understanding that relationship between the numbers. So that's why we have really advocated for all of my high school teachers teach numeracy in all of their classes, Algebra 2, all of them, and now they want to take it even further. So as part of the curriculum, we were using numeracy strategies as warm-ups this year, and it was part of the complete ninth grade curriculum for their first 3 quarters of their year, and teaching these strategies. And now we want to move into more impactful and using the bigger picture of the problem strings. Linda?
Well, I just wanted to add that these are some more examples that actually come right from Pamela Harris's website. I included the email, or excuse me, the URLs down at the bottom of the screen, but if you simply go to mathisfigureoutable.com and snoop around, she has some really great resources there. But these problem strings demonstrate that these do not just have to be your basic skills from elementary school, that you can take these strategies, these tools, and you can carry them on into Algebra 1, Algebra 2, even geometric purposes. So we just wanted to throw that out there if you're still feeling like, but this isn't my content, or this isn't what I am supposed to be teaching as a secondary teacher. I'd actually encourage you to investigate having number talks with your students during their warm-up time in using numeracy skills, but that's, again, it's another PD for another day. But we just wanted to show you that there is a bigger picture than simply doing this for the sake of students improving their numeracy, that it will impact, as Keir said, so much more of what they're doing in the classroom. So we did include some resources here if you want to pause this when you're playing back and investigate those. The video that you see, or excuse me, the graphics that you see here are the books that we use to support our work. We've also had some professional development from Pamela Harris, and so would encourage you to use her resources as well. And finally, on the last screen, we'd like to show you our contact information. If you would like to reach out to either of us, we're happy to answer your questions and steer you in the right direction of how to continue your investigation and your work in numeracy. We want to thank you for your time and for spending an hour with us today. And feel free to reach out to us if you need anything. I don't know if you have any closing comments, Keir?
No, but I do encourage you, feel free to email us, and again, we're continuing and adding and expanding this numeracy and the problem strings. We see that it can really help our students all the way through to calculus. So we're very excited about implementing these strategies for students.
Thank you.
Great job.
Thanks.